So welcome. So this is the first of 5 hopefully short videos to show you how to do your own meta-analysis using the Hunter and Schmidt meta-analysis program version 2. So this one I just want to show you some things that you need to do to get started, what the different options are for conducting the meta-analysis, and then depending on the meta-analysis that you're doing, you'll want to look at one of the 4 remaining ones. So the first thing I want you to notice notice is that here I'm in Windows Explorer. I'm looking at my computer, and as the README file says, I've created a directory in my off my C directory, off my main C directory for meta-analysis programs. A lot of files produced by the program are saved to subdirectories of this meta-analysis program. So if you, say, put it on your desktop, the things that you try to do within the program will fail. So it has to be off the C directory. So when I come into here, the link to run the program is the Hunter Schmidt meta-analysis program. I've already launched that, so I'll show you, but if you were starting, you would just double-click that and to launch the program. But first I want to show you this file that I've set up. So let's say that this is the data that you've created off of your coding. So you've created a spreadsheet in Excel to code your studies, and so you see the study numbers, you see your effect sizes, and then you have sample sizes, reliability of the dependent variable, and over here you have a number of different moderators. One of the things that I've learned is, even though you may have set up a really good spreadsheet that contains all of your information, when you begin running the meta-analysis, you're going to have to re-input that data. You have 2 options. You either have to re-input that data, or you would have had to set up your data in the exact format in Excel that the program requires. So if you had known that, you might have created your spreadsheet a little bit differently, but it's just going to create one extra step where you have to input your data. So what I've done is I've printed this data, and I'll show you in another video how I would input it. But I just want to point out a couple of things here. Things like study size, study number is self-explanatory. The effect size should be self-explanatory. These are uncorrected. If you're analyzing experimental effects, d-values, and you have equal sample sizes across your 2 groups, all you need to do is put the overall sample size in this N1 column and put zeros in the other. But if you notice in study 9, they have unequal N's, and so in this case the total N is 60, but I had to put a 35 in one group and a 25 in the other. When I have the reliabilities given to me by the study, and this is assuming that I'm going to do individual level corrections, if I have the reliabilities, I place them in the reliability column. If I don't know the reliability, if it's not provided or I can't estimate it from some other study, I would put a 99, and the program should read that as a missing value. And then over here, actually in columns A through F, this is what the meta-analysis program is going to read, and you're going to, within the meta-analysis program, recreate this, but using the input function. But what I'm showing you now is something that is modeling the coding sheet you've created. If you've coded multiple moderators, my understanding of the program is you can only do one moderator at once. So what you're going to have to do is, for example, if you want to look at whether the study is published or not, you would create that, you would set that up as the different levels of the moderator. You would run the analysis, you would load the data that you had saved, and then you would re-enter or modify these moderator values, say, with a second set of values. One other thing I learned the hard way is, if you look at the comment, for moderator analyses, you would enter values such as 1, 2, 3, depending on the different levels or categories, you don't want to use a 0. So if you're thinking about kind of dummy coding 0 and 1s, that won't work. It has to be 1 or greater. So I've set up my spreadsheet for coding. I've recorded this information in a place that's easy accessible. I've printed that so I can refer to it for data entry, and then I go and I launch the program, and it looks like this. So actually it doesn't look like this, it looks like this. When you first go into the program, you'll see something that looks like this. You can exit the program here. You can print or view the README file, and I would encourage you to print that. Read it carefully before you do the analyses. There's a few things that are a little bit subtle, but they're usually well explained in the README file. And it would also be helpful to have that open. There's a couple extras here, and I want to show you what those look like. You can do two different things. You can calculate a point biserial correlation, or a biserial correlation from a point biserial correlation. So let's say that you're looking at the experimental effects of something on test scores, which you think are normally distributed, but they only, in the study, they only look at pass-fail. You might want to do this correction, and the spreadsheet looks pretty simple. It looks just like this. You would enter in the point biserial correlation given by the study, your sample sizes, everything else down here is calculated automatically, and it would give you the point biserial correlation, which is a better estimate of the treatment effect. And this is described on, I think, pages 268 and 269 of the book. The other thing that I can do is, particularly if I'm doing a validity generalization study, is estimate the composite correlations. These are described beginning around page 441 of the book, and they make an argument that this is a much better way of treating situations. Say you have an effect relationship between an independent variable and dependent variable, and say you have 3 markers of that dependent variable. Instead of averaging the correlations of the IV with each of those, you'd want to look at the composite correlation. And this is, again, another spreadsheet. It didn't come up. Let me try to launch that one more time. It's not going to work again, but it's pretty simple. It'll just show you it just has what looks like a correlation table, and it asks you to put the correlations among, say, the dependent variables, among the independent variables if you had multiple independent variables, the correlations, cross correlations between the independent and dependent variables, and it calculates the composite correlation. And Schmidt and Hunter make a nice case for why it's better to use the composite correlation. So that's up here. I described the README. So if you want to get started, and this is actually where we're going to end this video, you click here to start, and here you see the 4 different types of meta-analyses that you can do. So if you're looking at field data, correlational data, you have 2 options. One is when each study you have sufficient data to correct for individual artifacts. If you don't have enough data and you want to use artifact distributions, this is a somewhat more complex data entry process. And then you have the same 2 options for effect sizes, values D, one where you can do individual study level corrections, and one where you don't have sufficient data but you can build artifact distributions as described in the textbook. So when we come back, you'll be able to, depending on which of these 4 you want to do, I'll be able to walk you through each of these.